Hello, good afternoon. Okay, let me see. We have two students right here. So before I start our today's class, I would like to talk about the project, the topic, and then I would like to ask you to get in the background. Also, I received the email when you asked about like, can you resubmit it? So because I just want to help you to like maintain the progress of your project. So that's why I asked you to submit the project topics and then have some background. So if you see I didn't give you the like the full map, then you can modify and upload it one more time. So it's still okay. So you just let me know once you update the files that I will update it again. So I just want to help you to keep track and make sure you're on the right track, okay, for your project. If I look at your project, like in when you submit it, I am expecting like what are you really actually like developing? So like what kind of things? So more if you look at the scope. So you should able to tell me, of course, you're welcome to like tell me what's the backgrounds, what you're going to use, set environment. But if I cannot really see how you actually what kind of things you're going to implement. So let's say if you are implement API server for the web application, then you should let me know, okay, maybe including some functional, non-functional requirements, some performance. And let's say if you have the login and maybe you have the like, if I using the online bookstore, then maybe I can allow the user to input the records and then some books information, maybe some publisher allowed to do that, and then allow the user to search it. So at least you give me the outline of your project, like what you wanted to implement. So it will help me to easier to give you some suggestion or like what kind of function you should implement. Okay. And basically here's the planning, here's like first step for your project's planning and design. So at least you should able to tell me the outline. Okay, those functions. Okay. So based on this, then you can use the different approach, like maybe your database or how to implement. If you are using my example, you are welcome to use the Happy.js to implement your API server. But you say no, I would like to use another framework. Let's say Express. If you see some example, Express is one of the popular framework using for Node.js to implement the API server. Then I say, okay, I would like to use Express. Then feel free to do that. They're not limited. And then because another example is using the MongoDB. But if you say, okay, I want to have a better understanding on MySQL and also MongoDB, so I want to mix them together. So I will have two different types like relational database and NoSQL non-relational. You're fine. So you can implement like this. And you just tell me, okay, why are you going to design this way? Why are you mixing two database system? Okay, so make it like why it makes sense. Okay, so maybe for some data, so we did like preset like user information account, so I can use the relational database. But for something I need to have a faster like retrieval, like search it faster, so I apply the like more like in real time. So I will use the NoSQL MongoDB like this. Then I know, okay, so I don't know what are you going to do. So I can give you some suggestions or how can I help you to work on your project. So far here's like what's the requirement of your project outline. Okay, I will wait. I didn't see. I will wait. If you have some question, then you may ask me. I will repeat one more time. Let me know if you are ready. Okay.
Okay, I got my
Okay.
audio working.
Okay. Perfect. Okay. So do you catch what I'm expecting? What do you need to put on your your project topics and
Yeah, I redid mine and I did it based on the guidelines, so it should be good now.
Okay, good, perfect. Because when I look at yours, the only one thing, because you try to tell me lots of information like for something introduce a background like AWS, those things. You may use it, you may like include it, but I still not like I expecting like at least one paragraph. You are telling you what you want to do and then what kind of like something maybe function or functional things or like non-functional requirements you are going to put over there. So
Okay.
okay, so once you put it, I can update I will update your grade. So don't worry about the first part. And because I want to there are only 2 students right here. I want to see if you want, I can break down the submission to 2 parts. So right now is on Monday 11th. So if you want, I can give you the maybe around 1 week to submit like certain progress. So do you think it can help you?
Sure.
Maybe
Yeah.
around 1 to 2 weeks. So at least before you submit your project, at least I will look at it and give you some like of course the final grade I cannot guarantee, but at least you have some progress. I can like at least you have fundamental, maybe at least get a pass or something like this. So it won't like out of the track. Okay. So if
Okay.
you are okay, then I will add just like have like call part 1 and part 2. So you
Sure.
can see part of your work. Okay.
Yeah, that
Not
works.
submit but when you try to work on your project, remember to follow the structure. So give me your design. So maybe I will expecting after 2 weeks later, maybe I give you 2 weeks. So you have some scope and then some structures, and you maybe already start to implement like on some well, if you we use those source code, and I expecting you can launch your API server, even with the simple basic functions within 2 weeks. So you should able to do that if you follow all the assignments, right? Okay. And remember one thing, I will appreciate if you can try to work on the using the Git. So try to like using Git and then push it, and then you can clone to your server. Sometimes if you're working on locally, and after you finish the implementation, you will git push to your to a repo and then clone it from or pull it from your Git to your AWS server. So you can do it in this way. This is like for better practice. Okay. And for today, if we're all ready, then we will move on the new topic. So it will about our some encryption and decryption. So because if you're taking the 422 did you learn something related to the some different type of encryption and decryption methods?
Yeah.
Okay. And let's say if I talk about symmetric, asymmetric, so encryption, or do you know how to do that?
Yeah, we've covered that.
Okay, good, perfect. So slightly overlap, and I will try to like add more slightly. Okay, so first we need to know because in this course we will talk about the cloud computing and the security. So what are those security? We did cover in our previous lectures before, and then what are actually the encryption methods? We are not yet about to talk about that. So we have different type of models for and then deploy, and then we have some encryption theory principles we need to know from plain text to ciphertext, and then providing encryption keys. So this is nowadays. And then we have the symmetric, asymmetric encryption. So we need to look at those like pros and cons. And then what are the algorithms? Just like if you did learn it, it just help you to do reversion. And those like, let's say that we talk about the AES, RSA. And so we download the keys. If you use the AWS EC2, we need to download the keys. So if you remember, we need to generate the login key. Then we're using the RSA, and then what's the format, and then some real example, and what those like cloud securities, models, architecture. So we can, okay. And how can we secure the data storage? How can we protect those? So these are things. And one more, this is the first time you can hear the terms for the E2E, so encryption. Sometimes you will know is the maybe the AES symmetric, maybe your first time like about the messaging, the app, cloud storage, and we'll look at those like the some security twists or mitigations, or how can we increase the better practice for cloud security. Okay. Again, so start with the go through one more time. So if you see the question, maybe always asking you what's the cloud. So we will including try to deliver the computing surface. Let's say our storage, processing power, database, all this. They're all cloud. Okay, filtering the internet. So we say most the time we use a pay-as-you-go model. And those public cloud we using AWS is one of the example. Other popular will be Microsoft Azure and then Google Cloud. So they're all available to public. And then we have the private cloud. So they are dedicated resources for single organization. And hybrid, we just combine the public and private cloud together. So we just have a higher flexibility. And we're community cloud. So we share the resources for specific groups or community. Okay. Then we know the structure, all these are different type of cloud, then we will need to know the like security, why they matter. So first, like we will increase the target on the cloud system because they host a massive amount of data. So that's why now we are raising lots of cyber the twist is always increasing. And then we need to like adherence like to laws, like different type of law. Then we are not really have to go through all the details of laws, but we have those like regulation. And next is the shared responsibility. So we need to know if we have the cloud provider and then the client, so who will take care? Okay, so security of the cloud and cloud security in the cloud. So here would be two different times. Security of the cloud would be the cloud provider. So make sure the infrastructure of it, like how can protect. And then we need to, if you remember, we talk about the application. So here term we say like security in the cloud. So we'll be on client side. How can you make sure your application like with high security? Okay. And those challenge we did in some cases share. So we have the data branches. So we have some authorized access to data stored in the cloud. So lots that happen, those that bank always happen. And we have the loss of sensitive data. So we lost it. So maybe some accidents or malicious ad. So some certain attack. And then account hijacking. So we attacker try to gain some unauthorized access to the cloud service account. Sometimes we can fool, if you still remember, we have some different type of attacks, maybe some like cross site, like by input field or other method like treasury holes, like those things. And also the insecure APIs. So here, insecure API, also that's what you need to work on your project and be aware, because the weakness of in the cloud service API, the attackers then exploit. So if you didn't implement certain like security issue, like doing validation checking, then they will be the one of the gateway path, like let the attacker to attack your server and access to your data. So when you implement one thing, you need to consider how can you increase the security level. Okay, and then the next, if you mention maybe your project will to control the IAM, those things, then also you need to be careful. And of course, you need to set those like access right. And for the limited visibility and also control, so the organization may not have a full control over the cloud infrastructure, especially in those like multi-tenant environment. So all this, because we provided by the service provider, so and then we have some like some certain risk factor. So like some multi-tenancy, so we will share the physical infrastructure in the cloud. It happened to me. If you are sharing, especially using like AWS or other company, if one of the hardware, maybe your image or copy has been like injected by certain file, and sometimes because they try to maybe some worms or like triggers, they try to modify and access other copy or image located on the same physical infrastructure, then you may affect other image. Okay, so they will alter their source code or like change their boot. So it may possible that maybe all the some of the customers share on the same server, then it may be affected. Even though you have a high protection, but because like one of the image being attacked, modify, alter, and then they can send a root command like root or admin command to yours and alter. So just like be careful. Even you try to increase the protect the external attack, but that kind of more likely internal. And then next will be the data residency and the sovereignty, and then ensure the data remains in the certain jurisdiction. And then also their lack of encryption. So we need to make sure that data unprotected during the in transit or while stored in the cloud. So like this. And basically, if we know all the backgrounds, everything, then we will move on about some fundamentals of the encryptions and then the decryption. So for the encryption, so it's basically the process we try to converting the data into a form that like unreadable to anyone, except those have the decryption key. So it try to ensure the data confidentiality and privacy. Okay. And then for decryption, it's just a reverse process. So we try to turning the encrypted data back to its original form. So sometimes we use the term like plain text to the ciphertext, from ciphertext and then decrypt to the back to the plain text. Okay. So right here, plain text we always try to put is the original and readable data. And for the ciphertext, so those that encrypted data, so that is like unreadable without the key. And when we talk about the key, so we have the called encryption key. So it would be a piece of data used to perform the encryption. So that we pass the function, and those function will use the key. And decryption key, so it's a piece of data we use to decrypt the ciphertext back to the plain text. Okay, and in the later we talk about symmetric and asymmetric. So it can be a same key if it's a symmetric, but if we are using asymmetric, then it will be a different key. Okay. Then why we need to have a encryption and decryption? So mainly would be because the confidentiality. So we try to make sure data access only to the authorized party. Okay, it makes sense. And integrity. So try to verify the data. They had not been like tampered. Okay, they didn't modify. And now replication. So we make sure the action. So those are sending the data, they cannot be denied. So basically, that's why we need to have the encryption, decryption. Okay. And more like trying to make it more like crucial for encryption, also including data protection. So what we want to protect like sensitive data, and then there's some stored data and in transit. So when we try to transfer, Here's the one to apply. Let's say if you want to log in, then you create the API. So from your website, then how we're going to transfer the username and password or email and password to your API server. So are you going to encrypt it? Are you just like sending through the URL using get method and then without decryption, without encryption and decryption? Then that means that as a middleman or somebody able to steal, then may be able to see all of these like user email and then the password. They can steal everything. And then also we try to meet the data protection laws and regulation. And then we try to prevent some unauthorized access. So if even they access our data, so we can make sure the encrypted data, they won't be readable. So without the key. So here's the advantage. Even the purpose that we cannot avoid our data or like being stolen, but at least we decrypt it, they cannot easily to read it. And here's the main idea, like when we try to implement those using key or like increase the length. If you know the password we using right now, maybe introduced long time ago. So they were introduced using the uppercase, lowercase, and then some number, and then special character. Okay, and it's helpful because like when they introduced, but when later, I think it was last year, pretty recently. So the one who introduced this method and just like saying a project actually compare with the how complicated of the password, it's better to have a longer password. Longer password is taking much longer time to match the combination. Of course, when you're using letter, numbers, uppercase, lowercase, the variation is higher. And then when you have the longer, it will be, let's say if we have from A to Z and then upper and lowercase, we at least have 52. And then if we include numbers, so we have 9 digits with 61, and then if we have, and then we power to the length of your password. If your password is 15 digit long, then it will be powered to 15. So it may take really long time for the attacker to find your actual password. So it takes longer time. Okay. So it will let them to maybe give up, or they will try to change their target. Okay. So far right here, so in the real world example, let's say the cloud storage service like AWS S3 or the cloud storage by Google. So they will automatically encrypt the data. So even though you don't need, they will help you to do that. So this one is more in the security of the cloud, so they provide by you. But of course, yourself maybe need to choose like how can you encrypt your data too. And also we using HTTPS, usually able to know when it was the S and how can you use it. So it will ensure the secure communication over the internet when using the SSL and TLS for encryption. And when we talk about encryption, we mainly have two different types. One is symmetric, and another one is the asymmetric. And then for the symmetric one, so we are sharing the same key. So we say the encrypt and then decrypt the data will be using the same key. Advantage is it will be faster. Okay. But in the theft side, because we are using the same key, that means that it will be challenging because for the key management, because when we are components, that then all the data will be decrypted. Okay. Also, if we are sending the key, the encryption key, also your decryption key, because it's the same one. Through the internet. That means if I'm the attacker, like in the middle, if I able to steal your key, then I can decrypt your data, and either I can steal your sensitive information. Also, I can modify your original message and then encrypt it one more time and forward to you. Just like imagine if you're logged in and then sending a payment. Okay. If I am able to read it, so I may be able to see all your bank information, contact, and then maybe I will change the destination, maybe the routing number and the bank account number that I forward to you. So maybe you will, okay, send the money to the wrong user, okay, like this. And one of the popular algorithm is called the AES. We call it Advanced Encryption Standards. So this one. And another one will be the asymmetric. We'll say, so we'll use the two keys. So one is called a public key for encryption and private key for decryption. And if somebody, if you know, then I'll ask you a question. Because some I also teach in cybersecurity, but that one is like more like I spend more time on showing how it works. So you know who, if for encryption and for decryption. So let's say if you want to send me a message, then which key you will use, and then which key will I use? Can you catch my question? So if I asking for the asymmetric, do you like, can you guess? Can tell me, okay. Even you look at here, for public key I use for encryption, and then for private key is for decryption. Let's say that means like within the communication, let's say we have A and B. Okay. So if B want to send a message to A, then which key should you use? Because let's say we have A and B, then we have the public key of A, and then we have the private key of A, and then we have the public key of B, and then private key of B. Okay, we have two. So if B wants to send a message to A, then which key should be used?
B. Can you hear me?
Okay, yeah, you may answer me. Okay.
I'm sorry. Yeah, can you hear me?
Yeah, sure, I can
Oh,
hear.
okay.
Okay.
For B, and B was send as public key, or encrypt it with the secret key, and then send as public key to A, where they would use that public key to and their private key to decrypt. Or sorry, the B's public key.
Okay, so you say I will use B's public key to encrypt the message, and then say to B to A. That's what you mean?
No, you would use your private key to encrypt the message, but then also the receiver would use your public key to decrypt.
Decrypt. If I understood it correctly, maybe what you're telling is more slightly advanced level. So actually if in case because what you're saying right now actually something partially correct is about in an advanced level we also want to protect the key. And if just like this just back to a really fundamental way is like if I want to send a message to A, then B need to use A's public key to encrypt the message. Okay, so once A receive it, then I use my private key to decrypt it.
Okay.
Okay, so it's really simple. So just remember who which key should I give? Let's say if this time maybe B want to receive a message from A, then A will use B's public key. So will be B's public key like this. Let me put it in this way to encrypt the message. Okay. Then I will send it to B. Okay. So when B receive it, then B will use their private key to decrypt the message. Okay, that's how it works. Okay. If you see a question I ask you, okay, then you should able to know, or you need to remember, okay, so I need to use whose key to doing encryption and decryption. Okay, and in advanced level, because we need to validate the key, then we will use it. But in this moment right now, you don't have to know, and I would show you later. Okay, how to because when we also sending the key, I want to make sure, or the content I need to validate, right? Then how can we do that? Then we can, I will show later. And then what's the advantage? Because we want to provide more secure for the communication. So because we never share the private key. So that means that even because we have a different key, if you want to decrypt it, you may be not able to decrypt it. You are only able to encrypt it, but because you never know what is my private key, so you are not always never able to decrypt it, just like this. Okay, and the disadvantage, the cons is always lower than symmetric because we need to generate the key, and then it takes more time, and then we need to go to different algorithm. So it's more harder. One of the example used is RSA or ECC, the elliptic curve cryptography. And for the later we the time enough, then I will give you more some exercise. If not, just go through the ideas. And then we will talk about the example of the AES. Because AES we use a lot, and if you remember, I sometimes talk about. So for the AES is called the advanced encryption standard. So it's a widely used. It's a block cipher. So we operate on a fixed size of block of data. We can define like 128 or 192 or 256. Nowadays, because we want to increase the security level, so we put the use 256, but it takes longer time to generate. And for AES, we are commonly using for encrypting the sensitive data in the database, file system, or cloud storage. So for local, it's still okay. And how it works, so basically we try to split the data into a fixed length of blocks. And we, based on the key we use, like 128, 192, or 256 bits. So we apply on each block using a verse like encryption runs. So mainly is that taking the runs, we're doing a shifting, I think. So maybe 10 runs we're using. So we go through like 10 runs, shifting, and then adding bit. So that's how it works. I will go through the theory, but one thing is like you need to know how to use it. Pretty common if you can use called the open SSL. So if you can check and then create use the command line ENC AES, and then we can define it's a 256, and then something like a CBCs, and then pass it in, and then with the files, and then encrypt it. So I would like to let you to try for this one. If you try to execute and then what's the output. So let's say if I have a message like this, and then I say time.txt cancel. Okay, I need to get a new position. Let's say test.txt. Maybe you need to, okay. Maybe you need to install it, but you need to check if you have it. So let's see. Right. Okay, right here. Then maybe you need using the define SSL, and then the ENC is like AES and 256 CBC, and then dash in. And the file I create is called a test.txt. And right here you will see, okay. So you see txt, and then we will output as the file So okay, maybe I got test.enc. So it's the encrypted file format. So maybe I use the password 12345 and then 12345. Okay. The preset key divided. Okay, so maybe we will use the Thai or PBK PDF2. Okay, so maybe something else will be better. Then maybe let me try. So let's try with this one. Then maybe we can try something else. Let me see the one now, because one now this one is already it already depreciate data. Let me see if something new. And you will see the encrypted file is right here. So if I want to open it, so it will change to the hex file. So you are not able to see what is the original file. And I would like to, by the end, I will give you some time to try, because you may not, I'm not so sure which environment you're using. And of course, we have different type of encryption. We can try and then give you some exercise. You can experience and then using different type of encryption method. Because for the maybe cybersecurity, maybe you will learn how they works, but this one maybe let you know how more likely practically how can use all this to increase the security level. So it's more likely is like practical things. Okay, and then AES is really common example. So you even here we try to use the AES for the encryption. It's really fast. When I execute even 256, it's taking seven terms, so it generates pretty quick. So we are executing the time, so pretty less than 1 minute. So you can already create the encrypt the file. Of course, because my content is pretty short, so it will even have a faster output. Okay, so the disadvantage is like the key distribution and management issue arise for multiple parties when they involved. Because we all know the symmetric. Also, like I guess, like if you are the attacker, you know, pretty common we are using AES. Then you say, okay, let's using the AES. Maybe I will try most of the common, maybe 256. Maybe I start with 256, just a reverse, like, okay, you're using shift. Then I just reverse, like shifting one more bit to the right, and then like this, and then adding the key. So it will be easier to hack and then guess what is the encryption pattern. Okay, and then another popular one we are using is the our RSA. So it's the example using the when we're using the asymmetric encryption. So mainly it will be based on the mathematical difficulties of like factoring the large prime numbers. So it will it's like widely used in secure communication. So we have the pair of keys. We have public key, so we use for the encryption, and private key we will use for decryption. I will go through show you how to do it, and then calculate for the exercise later and show you the steps. So you can practice how can you calculate, okay? And you need to know and how the RSA works. So we will generate two large prime numbers, and then we'll compute to get their products and then to form the modules. And then we will compute their public and private key. So, okay, even you look at this, maybe you have no idea, but I will show you the step later, okay? We can use like encrypted data of the recipient's public key. So that's what I asked. So we get it, and then when the recipient, that means the receiver, receive it, then how the decryption works, we just decrypt using your own private key, okay? That means if you are communicating with several people, say, then you have multiple key. Let's say A, maybe communicating with B, C, D, like this. Then for A itself, it owns the key will be including the public key and then the private key, right? But also A will keep B's public key, also C's public key, and then D's public key. Okay, for encryption. Okay. And for the steps, if you later I will give you the exercise, so you don't have to worry in this moment. So you maybe have no idea how the asymmetric of I know if you learn about it, then you will be easy to pick up. But it's a path that you need to know. So just I will give you the PQ and then the E and D. So it will be the equation. How you get the encryption, okay, and then decryption. So also for the asymmetric example we will pretty use a lot for the HTTPS and digital signatures and some email encryption. So right here, let's say if we have the message using the recipient public key, then we can using the OpenSSL. So we put it a lot, and then with the RS authorized, and then we have the encryption, and then we pass the key in key, and then we pass the recipient's public key. So the file form is PM, and then we're popping in and then passing the message, and then we will output was the encrypted message. We will simulate this, but I want to make sure if you are working on your symmetric first. And after I go through all the examples, then you can ask me the question. So I will give you the time. I will try to cover this one, the cloud security models. So after this, I will let you have practice on. For shared responsibility model, so it's about the cloud provider. So it's like responsible for securing the cloud infrastructure. And while the customer is responsible for securing their data, application, and use access. So here, so you know what's the security of cloud and security in cloud. Okay, so here's the difference right here. So we share the responsibility. And for the provider with responsibility, we always need to protect the underlying cloud infrastructure. And also they need to manage the hardware network virtualization layers. Because most of the server, maybe they build on the Kubernetes, and then they have different images, just like based on like paywall as well you go. So because if you request for one CPU, maybe 2 GB RAM, and then maybe 256 gigabytes, then they just like create a certain part of it, just like similar ideas like the VM. If you try to use VM on your own computer, so you need to declare, okay, so how many CPUs they can use, the RAM space, and then the storage they can take. Then once you execute, then part of your computer will running the virtual machine. Okay. All this like we can ensure the security of the data centers. Okay, so that's what I'm doing. And then for the customer responsibility. So like as us as a user, we need to secure the access control IAM. So the identity and access management. So when we learning like access to the Ubuntu, then you try to use that like CON, CHON, CHMO, and then change the like permission from 0, because by default is 777. So we write, and then you maybe lower it, or you need to change the user or the groups, and all this you need to do. And then try to encrypt the data at rest, like in the storage or like in transits, like sending. And then you need to manage the key encryption. So those are keys, and then data governance, all this. So for AWS itself, it also provides to like the IAMs for the role-based access, but also we are responsible to ensure that their data properly encrypted. So they do provide something functions to you, but also you need to use it. So for this, for the cloud encryption for better practice, always I use the strong strong encryption algorithm, like at least AES 256, like using longer to encrypt the data. And then also those like maybe the cloud provider, like maybe have some built-in encryption. Let's say the AWS S3, because right now we're using EC2, but for AWS, because they have different service, S3 is one of the service they provide, so they also have encryption. And then like Google Cloud Storage, they also have it. And then in transits, then what's the transits? We need to at least you have to use the SSL, TLS to secure the HTTP connection. When you build the just like some when you build your API server work on your project, because I know if you own your own domain, then you can try to use the support, the Let's Encrypt to create the SSL. And also in better practice, I will show you actually you can even increase higher security. Okay, but if you when you start your project, try to use the SSL for your API server. Okay, and ensure that your API server they are encrypted, and then to prevent the MITM. So we call a man in the middle attack. So they're always able to do that. And sometimes like man in the middle, I would like to show you the example. I will after this the key management, then I will stop right here in the lecture part. So we have something called the use the cloud native key management, like AWS like KS or Azure like KVault. So they for secure key storage and management. So they will rotate the key periodically and also ensure they are never hard-coded in application. So we always change the key. And I would like to show you one thing. Let me see. This one is the paid version, but you can check like you can use like called the Wireshark or maybe other application to detect it. So if sometimes it's the man in the middle, it's like how is it? Okay, right now I have some session, and I would like to show you one thing. Let me see. Let's say I have my IP address. Let me try to use. Then I try to connect my phone. So if you're interested, you can use your phone. So you can go to call the Popsy. So you can do it check it by yourself. Let's say I input my IP address. Then setting the port. Okay. So right now I showing, okay, here's the one on my phone I'm using right now. So I want to access it, I allow it. So right here, I will go to my phone, and then let's say if I open a browser. Okay, right now I have a Google, and then it comes out lots of things. And then all this will be sending through my phone. Okay, so I will able to see, let's say if I connect to the wireless campus, let me search it. So all this like moving, that means say the data is moving. So I will click on it. Wireless campus. And then I click on the menu, about. Okay, so I will stop it right here. Then just ignore because I'm using like maybe the schools like email gateway. So you see the gateway, and then the Manio online you're using right here, and then something like maybe my phone have a Facebook service like in the background. So you see right here. And also we have some message like most of them they were using Google, and then DoubleClick.net, maybe they will check keep checking your activities. And then Google account, YouTube, maybe I'm using right here, so they are sharing. And let's see, do we have something else more? Adobe's, I'm using Adobe's. So here will be all the service I'm using right here. And as a middleman, then I would know, okay. And if I want to still just like taking one of the example, let's say I have an image from YouTube or like some Google Analytics. So if I want to perform certain action, then I can look at it and then I will see, okay, what kind of data, and then we send it one more time, and then I will look at the content. But you see right here, all the content, like they are all encrypted. Okay, so you are hard to see. So if you didn't encrypt it, then if I, as a middleman, then I will see everything. So maybe if you didn't encrypt it, then you just putting your user name, password directly, then I will able to see it. So that's why you need to be careful and don't send your plain text directly. So you need to try to at least to encrypt it. Even as a middleman, I will see it's just like any random text or number. At least I need to looking for some way, some methods to decrypt it. Okay. So as a better practice. And right here, I will give you the time. So first I want to try to use the symmetric one. So you maybe use the SSL to encrypt. You can try to encrypt a text file and then try to check it. Okay, so that's what you can do right now. Also, if you have a question about your project, you can spend the time. I will help you and answer you. If you have no question, or if you want to do it by yourself anytime, then you feel free to leave. Okay, just let me know if you have any question.
I'm good. Thank you.
Okay, if no, then you can do it by your own. Okay, bye.
Yeah.
Okay.
Do.
Okay.
Have a good
Go
one,
on.
Professor.
Okay, you too.